Hello, I'm Suraj, and in today's video, we are going to discuss about DNA origami and the biocomputing techniques. The topics that are to be covered in this presentation are knowing about DNA origami and some of their applications, also knowing about DNA biocomputing concepts and its applications in various fields. What is DNA origami? It is the nanoscale folding of DNA to create 2 and 3 dimensional arbitrary shapes at the nanoscale. The 2 and 3 dimensional shapes of the DNA are shown to your right side in the figure. The DNA are 60 nanometer apart and 420 nanometer in their length. The specificity of the interactions between complementary base pairs make DNA a useful construction material through the design of its base sequences. DNA is a well understood material that is suitable for creating scaffolds that hold other molecules in place or to create structures all on its own. DNA origami has progressed past an art form and has found a number of applications from drug delivery systems to use as circuitry in plasmonic devices. However, most commercial applications remain in a concept or the testing phase. Next, coming to some of the applications of the deoxyribonucleic acid origami. First, it is used as a biophysical tool. Due to the structural designability and dynamic controllability of DNA self-assembly technology, DNA nanotechnology has been widely used in biophysics, especially in the study of single molecular systems. Next, it has applications in bionics. Due to the complexity of biological systems, it is difficult to study many scientific problems and phenomena the single molecule level, including nucleic acid analysis, motile protein movement, mechanism action, and of biological enzymes and nanopore sensing. Next, has applications in biological imaging. Biological imaging, it is an important research method to understand organism structure and to elucidate physiological functions by obtaining microstructural images of biological cells and tissues directly through optical or electron microscopy. Next, it has applications in genetic analysis. As the function of fragments of DNA molecules and genetic information material, genes play an irreplaceable role in predictive medicines, disease prevention, health management, personalized medical services. Next, it has application in cell drug delivery system. As a new mode of biological drug delivery, cell drug delivery can effectively avoid the risk of adverse reactions to large fluctuations of blood concentration and rapid degradation of genetic bloods. Finally, coming to the conclusion of DNA origami, this review first introduces the definition of DNA module and the theory and the development status of DNA origami, how it has evolved from generation to generation, followed by a detailed description of the applications of DNA self-assembly technology in various fields of natural science, especially in the field of biomedical. With the development of DNA computing, DNA self-assembly structures with different shapes and functions have been successfully constructed, but still, there are some of the challenges that are faced in DNA self-assembly technology. They are the following. First, there is no undefined DNA computer model to solve all kinds of problems. Second, the encoding affects the quality of hybridization and ultimately determines the feasibility and speed of DNA computing. The third is detection of solutions is an important problem in DNA, or else it cannot be solved. Next, coming to the fourth one, DNA self-assembly technology has developed to the level of arbitrary complex three-dimensional shapes, while most of the computational systems can only deal with two-dimensional DNA origami structure. This is the most common challenge that is faced. Next, the fifth one, there are some errors in the existing DNA recombination technology and the catalytic efficiency of enzymes cannot reach 100%, which will affect the efficiency and reliability of DNA calculations. Next is the sixth one. Although DNA computing has the unique advantage of simulating a wide range of physiological environments, that is, different temperature, enzymes, and the pH values, the stability of the calculations remain a challenge to every people. Coming to the next concept in this module, that is, what is biocomputing? Biocomputing, a cutting edge field of technology, operates at the intersection of biology, engineering, and computer science with three different branches. It seeks to use cells or the subcomponent molecules such as deoxyribonucleic acid or RNA, ribosenucleic acid, to perform functions traditionally performed by an electronic computer. The same way, DNA computing is an emerging branch of unconventional computing which uses DNA, biochemistry, and molecular biology hardware instead of the traditional electronic computing. The ultimate goal of biocomputing is to mimic some of the biological hardware of bodies like ours and to use it for our computing needs from less to more complicated. This includes the following. First, by using DNA or RNA as a medium of information storage and data processing. Second is connecting neurons to one another. It's the same way like how our nerves are connected in our brains. The same way the neurons are connected to one another. Third is designing computational hardware from the genome that level up. Cells already have. Cells are far more powerful at computing than the best computers in the world. For example, cells. They are the most important component in every living body. Second is receiving chemical inputs in RNA. Third is performing some of the chemical reactions using the ribosomes. Fourth is producing the output. Next, coming to some of the applications of biocomputing. First, it has the feature of multitasking. Regular computer perform one task at a time and switch quickly between tasks to give the user a seamless experience of multiple tasks running simultaneously. That is, it can do multitasking at a time and also parallelly doing the work at the same time. Next is overheating and high energy usage. Traditional computers use microchips which heat up very quickly. Supercomputers are usually a collection of several high speed traditional computers combined in a single unit. Generally, they are not qualitatively different from the traditional computers. Next is, they have a feature of self-organizing and also self-repairing. Biological molecules also display an intelligent ability to self-organize and self-repair. Next, coming to the conclusions of the biocomputing. While biocomputing is an early phase, biocomputers have the potential to enable far more powerful computing than today's best computers while using less energy and generating less heat. Furthermore, biocomputers will be able to use parallel computing, that is, doing the multitasking of different tasks, which will represent a significant improvement upon regular computing and will be able to better self organize and also self repair. While authorities estimate of the eventual environment impact of biocomputing do not yet exist. Biocomputing could potentially reduce our reliance on the silicon and rare earth minerals that power today's computers, that is, whole world's computers, day to day life. Thank you, everyone. I hope you have understood all the concepts that have been covered in this presentation and hope you enjoyed learning. Also, subscribe the channel to get more informations like this. Thank you, everyone.